Niels Henrik David Bohr was born on October 7, 1885, in Copenhagen. He grew up to be a Danish physicist. His father, Christian Bohr, was an eminent psychologist. His mother was Ellen Nee Alder, who grew up in a family that worked in the field of education. Niels grew up in an atmosphere that encouraged his genius. He studied physics at Copenhagen University and received his master's degree in 1909 in physics and his doctor's degree in 1911. While a student at Copenhagen, Niels entered a contest to find a solution to liquid surface tension. After submitting his paper last minute, he not only won the contest, but received a gold medal as well. This idea and many others were published in the Philosophical Transactions of the Royal Society in 1908.
He would go on to work with J.J. Thomson and Ernest Rutherford, who would eventually help him, along with Max Planck's early quantum theory, discover what happens inside an atom. He first hypothesized that a hydrogen atom transfers energy based on quantum theory. This led to identifying how electrons move in assigned orbits around the nucleus, answering why light is emitted in the atom's fixed wavelengths because of electrons jumping orbits, which emits a light quantum. Thus, he found the atomic model, which was used in 1913.
Before we go any further, Niels Bohr, being the scientist that he is, had to explain his big discoveries using scientific equations. The first one, energies for an electron in the shell, being E parentheses N parentheses equals -2 squared 1 times 13.6 eV. The second one, photon energy when electrons are absorbing and emitting photons, is HV equals angle E equals parentheses N low squared 1 minus N high squared 1 parentheses times 13.6 eV. Really complicated, isn't it? If you can't understand these equations at first glance, that's completely reasonable. You can't exactly read random numbers and letters that don't form sentences or even words, so let me try to break it down. Everything you see is a result of photons, which have reflected off the electrons in an object only to be absorbed by the electrons in the cells on your retina. All of the colors which your mind perceives are constructed from combination of relative intensities of these three wavelengths, red, green, and blue. In fact, if you get really close to a television, you can see these colors. These wavelengths are part of visible radiation on the electromagnetic spectrum. It's right between the infrared and ultraviolet radiation. Ultraviolet radiation is what comes off of the sun. It's what gives you sunburn and what causes skin cancer. Other powerful wavelengths you should watch out for are X-rays and gamma rays. Some of these can be really deadly in highly concentrated areas. Of course, an absorbed photon does not have to be re-emitted. Its energy can be used for chemical purposes. Photosynthesis and sight are two prime examples. When a photon hits your retina, it is absorbed and the energy is used to start the process of image formation. Absorption of photons by chlorophyll results in the production of molecules used by the plant to store energy. And in the process of fluorescence, photons are absorbed and stored for a relatively long period of time before being re-emitted. A visible object's color is determined by the frequencies which are not absorbed by its atomic electrons. Chalk is white because it absorbs primarily in the infrared and ultraviolet. Visible light is almost completely reflected. Copper compounds are blue-green because they absorb red photons and reflect most others. The exact frequencies are often shifted due to the surrounding atoms. Now enough of me rambling, back to the real slides.
This is known as the liquid drop model of the atomic nucleus. The model was a key step in understanding nuclear processes, and even explained the basis of nuclear fission. Nuclear fission is important for developing atomic bombs and concepts of quantum theory. Number 107 on the periodic table, Bohrium, was named after him. After his death in 1962, the Institute of Theoretical Physics, which he helped construct, was renamed to Niels Bohr Institute.
Now in the timeline of the atom's discovery and the way we picture it today, Bohr made his discovery right before Freddie Soddy thought of isotopes, and after Millikan did the oil droplet experiment to determine the charge of an electron. Bohr's discovery that there were more electrons in the outer orbit than the inner orbit revolutionized the way we see the atomic model today. This led to knowing an atom's chemical properties and Heisenberg's uncertainty principle.